In the world of DevOps, deployment is the process of delivering software applications to a production environment. This involves not only the application code, but also the underlying infrastructure, including databases. Effective deployment ensures that applications run smoothly and efficiently, minimizing downtime and errors. This presentation will delve into the intricacies of implementing deployments that include database tasks, a critical aspect of modern DevOps practices. Database tasks are essential in deployment because they ensure that the database schema and data are in sync with the application code. Without proper database tasks, deployments can lead to data inconsistencies, application errors, and even system failures. These tasks include schema migrations, data seeding, and database versioning, all of which are crucial for maintaining the integrity and performance of the application. Deploying databases comes with its own set of challenges. These include managing schema changes, ensuring data integrity, handling large volumes of data, and coordinating changes across multiple environments. Additionally, database deployments often require downtime, which can impact the availability of the application. Addressing these challenges requires careful planning and the use of specialized tools and techniques. Effective planning is the cornerstone of successful database deployments. This involves understanding the current state of the database, identifying the changes that need to be made, and determining the best way to implement those changes. Planning also includes defining rollback strategies in case something goes wrong during the deployment. By thoroughly planning database deployments, teams can minimize risks and ensure a smooth transition to the new state. Several tools can assist in database deployments, each offering unique features to address specific challenges. Popular tools include Liquibase, Flyway, and Redgate SQL Change Automation. These tools provide capabilities such as version control for database schemas, automated migrations, and rollback mechanisms. Choosing the right tool depends on the specific needs of the project and the existing technology stack. Automation is a key principle in DevOps, and database tasks are no exception. Automating database tasks can significantly reduce the risk of human error, speed up the deployment process, and ensure consistency across environments. This can be achieved using CI/CD pipelines that integrate with database deployment tools. Automation scripts can handle tasks such as schema migrations, data seeding, and running tests to verify the integrity of the database. Continuous integration and continuous deployment, CI/CD pipelines, are essential for automating database tasks. These pipelines can be configured to automatically apply database changes whenever new code is committed to the repository. This ensures that the database is always in sync with the application code. CI/CD pipelines can also include steps for running tests, performing backups, and rolling back changes if necessary. Schema migrations are a critical aspect of database deployments. They involve making changes to the database schema, such as adding or modifying tables, columns, and indexes. Schema migrations need to be carefully managed to avoid data loss and ensure compatibility with the application code. Tools like Liquibase and Flyway provide mechanisms for defining and applying schema migrations in a controlled and automated manner. Data seeding involves populating the database with initial data required for the application to function correctly. This can include reference data, test data, and default values. Data seeding is often performed as part of the deployment process to ensure that the database is in a known state. Automation scripts can be used to seed the database with the necessary data, ensuring consistency across different environments. Database versioning is the practice of keeping track of changes to the database schema over time. This is important for maintaining a history of changes, facilitating rollbacks, and ensuring that different environments are in sync. Versioning can be achieved using tools like Liquibase and Flyway, which provide mechanisms for tracking and applying changes in a controlled manner. Proper versioning practices are essential for managing complex database deployments. Despite careful planning, deployments can sometimes go wrong. Having a rollback strategy is crucial for mitigating the impact of failed deployments. Rollback strategies can include restoring database backups, reversing schema changes, and rolling back application code. Automated rollback mechanisms can be integrated into CI/CD pipelines to ensure that rollbacks can be performed quickly and reliably. By having a robust rollback strategy, teams can minimize downtime and recover from failures more effectively. Monitoring and validation are essential components of database deployments. Monitoring involves tracking the performance and health of the database to identify any issues that may arise after deployment. Validation involves running tests to ensure that the database is functioning correctly and that the data is consistent. Automated monitoring and validation tools can be integrated into CI/CD pipelines to provide real-time feedback and ensure the success of the deployment. To illustrate the concepts discussed, let's look at a case study of a successful database deployment. A software company needed to deploy a new version of their application, which included significant database changes. By using tools like Liquibase for schema migrations, automating tasks through CI/CD pipelines, and implementing robust rollback strategies, they were able to deploy the changes with minimal downtime and no data loss. This case study highlights the importance of careful planning, automation, and monitoring in achieving successful database deployments. To ensure successful database deployments, it's important to follow best practices. These include thoroughly planning and testing changes, using version control for database schemas, automating tasks through CI/CD pipelines, and implementing robust rollback strategies. Additionally, teams should continuously monitor the database and validate changes to ensure that everything is functioning correctly. By following these best practices, teams can minimize risks and achieve smooth, reliable deployments. In conclusion, implementing deployments that include database tasks is a critical aspect of modern DevOps practices. By carefully planning, using the right tools, automating tasks, and following best practices, teams can achieve successful database deployments with minimal risks. The next steps involve applying these concepts to your own projects, continuously improving your processes, and staying up to date with the latest tools and techniques in the field. By doing so, you can ensure that your deployments are efficient, reliable, and scalable.